So today I want to look at Hess's law. Hess's law is the enthalpy change in a chemical reaction is independent of the route taken for that chemical reaction or that chemical change to occur. So what that means is you'll have starting materials or reagents which then go on to products, and it doesn't matter how they get to those products, the overall enthalpy change will be the same. So what that means in practice is here we've got reagents, our reactants here are going to go to our products here. Now they may follow a route which takes them through two intermediates to get to the product, or they might go through some other intermediate to get to this product. But the overall enthalpy change from the reactant to the product is going to be the same. So if we look at the enthalpy change, so regardless of the route it takes, this difference here, and I'm showing an exothermic reaction, these reactants will make these products, and the overall energy will be constant regardless of what that intermediate is that it's had to get there. So how does that play out in how we use that information at A level? Okay, so what we have, how we construct our Hess cycle, we have our reactants here, and we have our products here. Now they can get from reactants to products, and they have an overall enthalpy change, just like we saw at this point here. So this is the overall enthalpy change, and in this case that would be negative, but that's what we're looking at here. So our reactants go to the products. Now they go to the products by going through some intermediate something or other. Okay, so this intermediate something, I'll call it other intermediates, reactants might go to the intermediates in this way, and the products might get to the intermediates that way, or our reactants might go to our products via a different route. So this is our enthalpy change. We might have our other intermediate here, or other something here, other intermediate or something. Okay, and it might be that we might be able to make the reactants and the products from this other intermediate or something. Here we might be able to make the intermediate something from the reactants and from the products. There'll be examples of this later on, but what we need to look at is if we can follow the arrows round, basically doesn't matter which route you go, it's going to have the same enthalpy change. So for instance, if we start from these reactants, let's follow the arrows. If we follow the arrows round to here, then this change will be the same as this change here. Okay, so if I call this 1 and 2, then the enthalpy change plus 2 is going to equal the enthalpy change at 1. Doesn't matter which way round you go, as Hess Law says, the enthalpy change in a chemical reaction is independent of the route taken for that chemical change. We're trying to find this enthalpy here. Doesn't matter which way we go, it'll be the same. So this is saying that, so we're conserving the enthalpy here. So what about this second route? So again, if we follow our arrows round, so if we try and get to the same product or the same reactant or the same intermediate following the arrows, you can see if we start from here, we can go via the reactants to our products, or we can go from our intermediate somethings to our products. The given data on here, the enthalpy to go from here to here would always be given. Maybe that is going to be, call it 3. The enthalpy from here is going to be 4. The enthalpy around this is going to be this conserved. So if we follow the arrows, then we can say 3 plus the enthalpy change that we're looking at is equal to the enthalpy change given there. Okay, so we're conserving enthalpy, we're conserving energy. I'll show you how to do that using examples in another video.